Okay, calculus class, here we are in your notes. Today we're going to be talking about the indefinite integral. And the definite integral is something you've already learned. Definite means that it has bounds. So bounds from a to b of f of x dx. And via your last test you learned that this was equal to big F of b minus big F of a, where f happens to be any antiderivative of little f. So as we introduce the indefinite integral, that is something that does not have bounds. As we talk about what that's equal to, I would like to just have you think about this. Suppose you have the antiderivative of, let's say, 3x squared, okay, dx. You would say, well, that's equal to x to the third. Because if you take the derivative of x to the third, you get 3x squared. Okay? And you see that this matches right here. So there we go. Well, what about, say, x to the third plus 5? If I take the derivative of that, is that not also 3x squared because the derivative of 5 is 0? Or suppose you have x cubed minus 20. I take the derivative of that. Is not that derivative also 3x squared? So it turns out that the antiderivative of 3x squared could be x cubed. Could be x cubed plus 5. Could be x cubed minus 20. Could really be any x cubed with a constant attached on the end. So therefore, the antiderivative of f of x dx, the indefinite integral with no bounds, we say is big F of x plus some constant. And that's the big idea for today. All right, the first type of problem that you're going to encounter in your work is to say, verify by differentiation that the formula is correct. So it's saying if I take the antiderivative of this, I get this. Or in other words, if I take x cosine of x minus sine of x plus c, and I were to take the derivative of that, I should get this thing. I should get negative x sine of x. Okay? So that's what I'm going to do. I'm going to take the derivative of the right-hand side, and I should produce the left. Well, as I take that derivative, I can see that I am required to use the product rule there. For this is f and this is g. The derivative of x is 1 times cosine of x plus x times the derivative of cosine of x is negative sine of x. The derivative of negative sine of x is negative cosine of x, and the derivative of c is 0. So you can see from this expression that I have positive cosine of x, I have a minus x sine of x, I have a minus cosine of x. Positive cosine and negative cosine will cancel, and I get negative x sine of x. That is the antiderivative. I'm sorry, that's the derivative of that, which matches here. So we verify by differentiation that's correct. If you look at the second one, it looks challenging. It's really not that bad at all. But as we glance at it, again, I want to say that 2 over 3a, anything that's not an x is simply a constant, times the square root of ax plus b, quantity cubed, plus c. If I were to take that derivative, I should end up with the square root of ax plus b. So I'll go ahead and take that derivative. I'm going to first rewrite it as 2/3, or 2 over 3a, times ax plus b raised to the 3/2 power. That's what that means. Third power, and then the square root sign. Okay, so 3/2 plus c, that derivative is going to be equal to that. So I'm going to use the chain rule here. And on the outside, I'm going to put 2 over 3a times u to the 3 halves. And on the inside, I will put ax plus b. The derivative of ax plus b is a. So if you're confused by that, if it was, say, 2x plus 3, the derivative of 2x plus 3 is 2. So it's just that number in front, so the derivative is a. And the derivative of this, notice how the 3 halves comes in front, and it will cancel out. So you'll get 1 over a times u to the 1 half. As I multiply these two together, okay, as I multiply those two together, notice that the a's will cancel as well. And you get u to the 1 half. And u is that guy. So square root of ax plus b. So we got it via the chain rule. So notice one we use the product rule, one we use the chain rule. So that's the first thing, to be able to verify by differentiation. I'll show you a couple of those problems, ones you'll want to try, ones you maybe won't want to try. But the majority of your assignment will be find the general indefinite integral. And this is going to be pretty straightforward. If you see this, you see that there are no bounds. There's no a, there's no b. So this is an indefinite integral. Anytime you see that, you'll attach c on the end as you find an antiderivative. So you already know how to do this. We will add 1, x to the 4/7 if we add 1, divided by 4/7 plus c. I don't leave a complex fraction, so I'll multiply by the reciprocal. 7x to the 4/7 over 4 plus c. That's the antiderivative. For the next one, we can't do it when it's in this form. We must distribute the 2x. So 2x times 1 is 2x. 2x times negative 3x is negative 6x squared. And 2x times x to the 5th is 2x to the 6th. The antiderivative of 2x is x squared. The antiderivative of 6x squared is 6x cubed over 3, or 2x cubed. I have 2x to the 7th over 7. And always remember plus c. If you forget a plus c on the test, it's minus 1/2 points each problem you do it. So please remember to do it. Here, I'm going to multiply it out. 1 times 2 is 2. 1 times 3g is 3g. Negative g times 2 is negative 2g. And I have a negative 3g squared dg. Or in other words, integral of 2 plus g minus 3g squared dg. I determined that by finding the antiderivative, which is 2g plus g squared over 2 minus g cubed, plus a constant. Always remember to add on the constant. Next one, the antiderivative of 2 sine of theta is negative 2 cosine of theta. And the antiderivative of 4 cosine is 4 sine of theta, plus a constant. Heard some people saying on this last test that they forgot how to find antiderivatives. It's going to be important moving forward. This is a great assignment to be able to practice some of those pieces. Okay, let's review a little bit of our trigonometry. Letter E. The integral of 3 over sine squared of x minus 1. There are some formulas that are important for you to know on the test. These are ones you want to carry with you. I gave you a sheet of notes at the very end, and it looks like this. These are various parts of calculus that we've talked about so far that are important to remember. If you look, I have all of your derivatives on this side. I have the product rule. I have the quotient rule. I have the chain rule. I have you know, derivative of sine, cosine, tangent, secant, cosecant, cotangent. I have all of your exponentials, your inverse trig functions, a lot of it's there. I also have some important trig substitutions to use. These are all really important ones right here. And then we have this double angle formula one as well right there that's important to use. I'm not going to make you remember all of them, but I will say you got to know this one. Sine squared plus cosine squared is 1. And you got to know 1 plus tangent squared is secant squared. And then the last one I'm going to say is know that sine of 2 times an angle is equal to 2 times the sine of that angle times the cosine of that angle. So as I reference that for this problem here, we can make some of these problems a little bit more simple. I know that sine squared of x plus cosine squared of x is equal to 1. If I subtract the 1 over and subtract the cosine squared over, I get sine squared of x minus 1 is equal to negative cosine squared of x. So therefore, I can make this substitution. This is the integral of 3 over negative cosine squared of x dx. Hopefully you also remember that the reciprocal of cosine is secant. So this becomes the integral of negative 3 secant squared of x dx. And now you know that the antiderivative of secant squared, this was a problem on your last homework from the last unit, trying to prepare you for what you're going to see, negative 3 tangent of x plus a constant. So I took it from a problem I did not know how to do and rewrote it in a way where I did know how to do it. Okay. Letter F looks challenging as well, but I notice that I have a single angle and a double angle. That's a sign that we need to substitute something in. And if you remember, your substitution is sine of 2x is equal to 2 times the sine of x times the cosine of x. So therefore, we have 3 times 2 sine of x cosine of x over cosine of x. That integral dx. Now that I've rewritten it, I notice that the cosines cancel, and I have the integral of 6 sine of x dx. The antiderivative of sine is negative cosine, so I have negative 6 cosine of x plus a constant. All right, now it says evaluate the following. This is to teach you the difference between an indefinite integral and a definite integral. These are definite integrals because they have bounds, so we will evaluate them. Though finding this antiderivative looks difficult. First, we're going to start with the 1 minus x to the 1/3 over x to the 1/2. You need to write this in polynomial form, which means we can't have this fraction here. We don't know how to deal with those antiderivatives. So I'll write it as 1 over x to the 1/2 minus x to the 1/3 over x to the 1/2. I'm getting closer. I can rewrite x to the 1/2 as x to the negative 1/2. And in this situation, when you have a exponents like that with a common base, we subtract the exponents, or 1/3 minus 1/2, or 2/6 minus 3/6. That would be x to the negative 1/6. Okay, so now I've written it in an appropriate form, and I will go ahead and find an antiderivative for x to the negative 1/2. I add 1 and I get x to the 1/2. I divide by 1/2 or multiply by 2. And for the next one, I'm going to add 1 and I get x to the 5/6. And I divide by 5/6 or multiply by 6/5. And then we would evaluate it at 2 and at 1. Just going to make sure you guys know how to plug these in correctly into your calculator. This one we're going to express as a decimal. 2 times the square root of 2. I'm plugging in 2, and the 1/2 is square root. minus 6 over 5 times 2 raised to the 5/6 power. And that gives me 0.690. And if I plug in 1, plugging in 1 is much easier. I'll just put on my calculator, but it's 2 times the square root of 1, which is obviously going to be 2, and then minus, say, 6 over 5 times 1 raised to the 5/6 power. And when you plug in that, you just get 0.8. So 0.69 minus 0.8, and we get a grand total of negative 0.11. That is the evaluation. Let's try letter H. Again, this is a definite integral. I will find the antiderivative. First of all, I'm going to rewrite it. Negative 3, negative 1, 4y, minus 3y to the negative 2 dy. The antiderivative of 4y is going to be 2y squared. The antiderivative of negative 3y to the negative 2, let's see, that would be negative 3y to the negative 1 divided by negative 1, otherwise known as 3 over y. I will evaluate that at negative 1 and at negative 3. Write my answer as a fraction here. Plug in negative 1. Negative 1 squared is 1 times 2 is 2. Plug in negative 1 and we get negative 3. Now I plug in negative 3. 18 and a negative 1. So I have negative 1 minus 17 is negative 18. Sometimes you come up with something that looks really challenging like this. We're going to make this next one easy. We're going to write it as the integral from 0 to pi over 4 of 1 over secant of theta plus tangent of theta over secant of theta. A little bit of review of your trigonometry for you. So I have the integral from 0 to pi over 4 of cosine of theta, as 1 over secant is the same as cosine, plus, and then tangent over secant, that would be sine of theta over cosine of theta, divided by 1 over cosine. The secant is 1 over cosine, and tangent is sine over cosine. Well, if I multiply by the reciprocal, notice what happens. Those signs cancel. So I have the integral from 0 to pi over 4 of cosine of theta plus sine of theta. Now the problem becomes pretty easy. The antiderivative of cosine is sine. And the antiderivative of sine is negative cosine. I plug in pi over 4. 45 degrees, the sine of 45 degrees is the root of 2 over 2. Cosine of 45 is the root of 2 over 2. Plug in 0 and I get 0. And plug in 0 and I get negative 1. This is 0, I get positive 1 in the end. The last example we have here, the antiderivative of cotangent times sine. Now, as we look at this antiderivative, we check it out here. The integral of pi over 6, pi over 3, and I can rewrite this as cosine of theta over sine of theta times sine of theta over 1 d theta. Notice here how the sines cancel. So I'm left with the antiderivative of cosine, which is just sine. I would like to evaluate that at pi over 3 and at pi over 6. You may recall that pi over 3 is 60 degrees and pi over 6 is 30 degrees. As you look at your triangles, that 30-degree angle is going to have root of 3 over 2 and 1/2. And that 60-degree angle is going to be at 1/2 root of 3 over 2. Remember that sine is the y values. And so the sine of pi over 3 is the root of 3 over 2. Minus the sine of pi over 6 is 1/2. So you get the root of 3 minus 1 all over 2. And there you have it. So we have definite integrals and we have indefinite integrals. Nothing really big that you need to learn that's new. Though I am going to go to my calculus worksheets here, and I'm going to find 5.4. The indefinite integral. And as I look at that one, I just want to help you out. You may want to kind of navigate slowly through this assignment and find the problems that you feel you can do or can't do. But just to review what we've kind of talked about, I think that there's a lot of students that have success with problem 1. And remember that you're going to be able to, the idea is you take the derivative of this and you should get that. And hint, you're going to use the chain rule there. For number 2, that usually goes okay for people. It's a similar example we did in class. Take the derivative of this and you should get that. That's the product rule. And then this one, you use the product rule and take the derivative of that and you should get that. Sometimes this one goes okay. These two are tough for people. So don't feel afraid if you struggle through those. But it's good algebra practice and kind of shores up some of our algebra responsibilities. It will come in handy later on. But if you'd like to skip over those and then go to some like these are pretty straightforward. People usually do well with all of these. And more definite than definite integrals here. Notice the difference between the definite and the indefinite, okay? And that's part of what you want to practice. So lots of practice for you. We'll have some time on Monday to ask some questions. There's only 4 assignments in this unit, so this is one of them. Plenty of problems to practice. Miss you guys. Hope you have a great, great weekend.